Alright, so today we are going to talk about the law of cosines and how we can use this to solve oblique triangles when given a different set of information than we use for the law of sines. So let's go ahead and check out those types of triangles. Alright, so we have the first two that we talked about for law of sines. The second two situations are then going to be what we will be solving using law of cosines. So if we know all three sides, we can use law of cosines to help us solve for a missing angle. Or if you know two sides and an included angle, then we can use law of sines to help us solve for the opposite side. In this case, we're solving for side B. Let's take a look at a few triangles set up to solve using the law of cosines. But first, let's talk about what the law of cosines actually is. There are two main forms. The first form is a standard form, and it's kind of convenient that standard form helps you solve for a side. See how they both start with S? That's kind of convenient. And the alternate form will help you solve for an angle. And they both start with an A. So standard form, solve for a side. Alternate form, solve for an angle. And you can see there's a fairly big difference between the two formulas. The other thing that you want to make note of is when you have the alternate form, we do have the cosine of our angle. To finish solving each one of these, you would have to take the cosine inverse of whatever this fraction ends up being. So once you have that decimal value, take the cosine inverse of it to finish solving for your actual angle. Okay, so now we have an example. And I want to make sure that we understand the type of example we have. So I have a side, then an angle, and another side, which means I'm going to be using this information to solve for the missing side B. Since I'm solving for a missing side, I'm going to have to use the standard form of law of cosines to solve for that. Okay, so let's go ahead and set up our equation to solve for that. To begin with, we have b squared is equal to a squared, which is 6.2, plus c squared, minus 2 times a times c times the cosine of b. Now, one other thing I want to kind of highlight here is you need to make sure you do these multiplications, or sorry, these algebraic steps separately, because sometimes what people will try and do is do all of the numbers first and then multiply by the cosine of 75. We don't want to do that. You want to do 6.2 squared plus 9.5 squared and get a number. And then do 2 times 6.2 times 9.5 times the cosine of 75 to get your other number, and finally subtract the 2. Alright, let's go ahead and take a look at what we get when we do that. Alright, so for our first set there, we get 128.69 approximately. Oops, 6 that. And then for a second set, we're going to get 30.49 approximately. We would have b squared equals all of that, which means b is going to equal the square root of, when I subtract those two things, I get approximately 98.2, or 20, which is approximately 9.9. So b is approximately 9.9. One of the nice things now is, since I know that b is 9.9, I do have a corresponding set of things. So I have angle b and I have side b. So I could very easily finish solving for either angle A or angle C by using the law of sines. So let's go ahead and set up a ratio to help us solve for angle A. When you're using the law of sines to solve for an angle, the angle is generally on top. If you're solving for a side, then the side's on top. That's why we have the two forms for law of sines. And what I mean by that is, if I'm going to solve for angle A, then I'm going to start with sine of A over 6.2. So the angle's on top instead of on the bottom. And that's going to equal the sine of 75 divided by 9.9. So I'm going to go ahead and multiply both sides by 6.2, and then I have to take the sine inverse. So I'm going to get something like A is equal to the sine inverse of 6.2 times the sine of 75 divided by 9.9. And I'm running out of room, so I'm just going to go ahead and write my answer up here, saying that angle A is equal to approximately 37.2 degrees. Once I know A and already know B, I can subtract each one of those from 180 degrees to get my final angle. So angle C is going to equal 67.8. Alright, so again, just to recap, we use the law of cosines to solve for a missing side B. And generally, once you've used the law of cosines once, you can continue using the law of sines to solve for whatever else is missing. You don't always have to. You can use the law of cosines, but it seems like the law of sines is a little bit simpler and easier to use than the law of cosines is. Alright, let's go ahead and take a look at another example. Alright, so here we start off by knowing all three sides, which means I'm going to automatically have to solve for an angle to begin with. And let's assume that I want to solve for angle C. Alright, so my ratio will start off as the cosine of C is equal to 6 squared plus 8 squared minus 12 squared divided by 2 times 6 times 8. And notice that for these two terms, they are the sides of that angle, and then the last one is the actual corresponding side for that angle. Okay, so when I go ahead and condense my fraction, I'm going to get that the cosine of C is equal to negative 44 over 96. And don't forget that I have to take the cosine inverse of that angle, which means C will equal the cosine inverse of, well, that fraction, which is approximately 117.3 degrees. Alright, so we have a similar process here if we wanted to solve for a different angle. Let's say now that we wanted to solve for angle B. So now we're down here. We would start with a cosine of B is equal to 12 squared plus 8 squared minus 6 squared divided by 2 times 12 times 8, which means that the cosine of B is equal to 172 over 192. Alright, from this step we would take the cosine inverse of that fraction, and if you did, then you get that B is approximately 26.4. Alright, now since I know those two angles, since I know that angle C is 117.3 and angle B is 26.4, I could very easily subtract those two from 180 degrees to get that angle A is 36.3. And there I have my three angles. Alright, it is word problem time. So we have a golfer, and he played his first tee shot a distance of 220 meters to point A. So here's his first tee shot, starting at T, going to A. Then he played another shot 165 meters to the green, so his second shot is going to go from A to G. And we know that the total distance from T to G is 340 meters. The question is, how far off was the golfer with his first shot? So, what is our initial angle? Since we know all three sides, we're going to go ahead and solve this using the law of cosines. So let's go ahead and take a look at how to set it up. Okay, so since I want to solve for T, I have that the cosine of T is equal to the two adjacent sides, which are 220 and 340, so 220 squared plus 340 squared, minus the opposite side, so minus 165 squared, divided by 2 times 220 times 340. Alright, so we have some large numbers, but that makes sense because we're dealing with some large numbers. We get that the cosine of T is equal to 136,775 divided by 149,600. Okay, our last step would be to take the cosine inverse of that fraction to get our final angle. And we get for our final answer that angle T is equal to 23.89 approximately degrees. Now, I'm no golfer, but that does not seem like a good first shot. Okay, now for our last example today, we're going to talk about a soccer goal. So we know that the goal is 5 meters wide. I'm just going to draw a goal. This distance here is 5 meters. We also know that when a player is 21 meters from one goal post and 19 from the other, that he shoots. So we have two sides of a triangle. One length is 21, one length is 19. So this one is 21, and this one is 19. The question is, what is the angle of view to the goal that the player sees? So what is this angle here? Again, we have all three sides. So when we set this up, we're going to use the law of cosines. And we're going to start by saying the cosine of, we'll call this angle A. So cosine of angle A is going to equal 21 squared plus 19 squared minus 5 squared divided by 2 times 21 times 19. Alright, so when I simplify that fraction, I get that the cosine of A is equal to 777, interesting number, divided by 798. And again, our last step is to take the cosine and inverse of that, and when you do, we get approximately 13.17 degrees. Alright, and there you have it for section 6.2, using law of cosines. Go ahead and wrap it up and start working on your homework.